In this question, there is a submarine which is located at these given coordinates relative to a ship positioned at the origin. And the directions are mentioned vis-a-vis the axis. X is due east, Y is north, Z is vertically upwards. All distances are in kilometers, and the direction vector of the submarine is given. We have to find the equation for the line along which it travels. So for the equation of the line, let's write down the basic equation. The general equation for a line in vector form is r is equal to a plus lambda b, where r stands for the position vector of any random point lying on the line. A stands for the position vector of the initial position. So in this case, that will be 0.8, 1.3 minus 0.3. Lambda is a variable parameter. B is the direction vector, which in the question they have given as -2, -3, and 1. So let's put all the values in. We'll get r vector equals to, so for A, it's the position vector of the initial position. Let's write that in the column form, 0.8, 1.3 minus 0.3 plus lambda times the direction vector is -2, -3, and 1. So that's the answer for part A. Moving ahead to part B, the submarine reaches the surface of the sea at point P and we are supposed to find the coordinates. The submarine reaching the surface of the sea implies that one of the coordinates has to be 0. Which coordinate will that be? So we look at the directions. X is east, Y is north, but the Z is vertically upwards. So the Z direction is basically the submarine going up and down. So when the submarine reaches the surface of the sea, it's the Z coordinate, the Z coordinate of the submarine, which is equal to 0. Let's use the vector equation of the line to get the Z coordinate. So let's say if we simplify this entire vector equation, the X coordinate will be 0.8 plus lambda into -2. Y is 1.3 plus lambda into -3. Similarly, the Z coordinate, which we require, is -0.3 plus lambda into 1. So I'll only write down the Z coordinate here. We'll write -0.3 plus lambda into 1. Since the Z coordinate is supposed to be 0, we put the Z coordinate as 0. So lambda comes out as 0.3. And now if we try to get the coordinates, X coordinate was 0.8 plus lambda into -2. So let's write that down. X will be 0.8 plus lambda into -2. So we will put lambda is 0.3 in this particular case. And solving this, we get 0.2 as the answer for the X coordinate. Y coordinate will be 1.3 plus lambda into -3. So let's write that down. 1.3 plus lambda into -3. If we put the value of lambda as 0.3, the Y coordinate comes out as 0.4. And the Z coordinate, of course, is 0. So the answer for the B1 part is 0.2, 0.4, 0. B2 part, find OP. OP is the length of the line segment OP, which in this case we will represent as the magnitude or the modulus of vector OP, because that's the definition of magnitude, the length of the line segment. OP vector, let's write down, will be written as 0.2i plus 0.4j plus 0k. And we use the formula square root x square plus y square plus z square. So the magnitude will become this. And if you solve this square root expression, we'll get 0.447 as the answer. And for the units, we go back to the question. All the distances are measured in kilometers. So the final answer is also in kilometer. It will be 0.447 kilometers, which can also be written as 447 meters.